Hi everyone! In this video, we want to tackle some advanced factoring problems. And these are typically the types of problems that pop up in advanced calculus. So we're going to utilize our basic factoring skills and hopefully apply those skills in these more advanced scenarios. Part A, 4x to the 2/3 power minus 12x to the 1/3 power. So we have two terms here, and our first order of business is to determine if there is a greatest common factor. So we'll start by just taking a look at the coefficients, 4 and 12. We know the greatest common factor between 4 and 12 is just 4. But when we deal with x to the 2/3 and x to the 1/3, those fractional exponents can sometimes throw people for a loop. So let me pause for just a minute and let me go look at a simpler problem, one that I'm confident you would all factor correctly. So for example, if I asked you to factor, let's say x to the 4th minus x to the 7th. Here, you know that your greatest common factor would be x to the 4th power. Notice that between the two exponents, we took the smaller exponent. We know that x to the 4th divides evenly into x to the 7th. That's why x to the 4th is our greatest common factor. It's the smaller of the two exponents. So let's apply that same idea here. We have x to the 2/3 and x to the 1/3. So we need to take the smaller exponent. In this case, the smaller exponent is the 1/3. So our greatest common factor will be 4x to the 1/3 power. Now, remember, I'm going to leave a little space here. I'm going to factor out 4x to the 1/3. But essentially, when we're factoring, we are dividing each of these terms by that greatest common factor. So I'm going to go ahead and show this division. And many of you will find you don't need to show the division, but this does help clarify how we get our final answer if you have a hard time seeing it. So we're dividing each term by 4x to the 1/3 power, and then we'll just do the division. So we know 4 divides into 4 one time, and then we have x to the 2/3 divided by x to the 1/3. Remember, in this case, we would subtract our exponents. So 2/3 minus 1/3. That'll leave us with 1/3. So we would have x to the 1/3 power minus 4 divides into 12 3 times, and then we have x to the 1/3 divided by x to the 1/3. So therefore, we would be left with just a minus 3. So our first problem is fully factored. Now we have 4x to the 1/3 times x to the 1/3 minus 3. Let's take a look at B. So B is another problem that also has two terms. I'm going to underline the terms here. We have a term here and a second term here. Remember, terms are separated by addition and subtraction. So this addition here is separating these two terms. So just like before, we've got to determine that greatest common factor first. So between -5 and +10, I'm going to go ahead and choose to factor out a negative with the GCF. So I'll choose -5. Then you can see we have e to the x and e to the x. So we can factor out an e to the x. And then lastly, we have 2x minus 1, and then over here we have 2x minus 1 squared. So just like in the last example, we are taking a look at the smaller of the two exponents. So in this case, we can only factor out a 2x minus 1 to the 1st power. So there's my greatest common factor, which I will factor out. When we say we're factoring, though, remember, to factor means you're rewriting the problem, you're rewriting it as multiplication. So ultimately, we're rewriting this as a multiplication problem. So to do so, we're dividing each of these terms by that greatest common factor. Again, this is a step that many of you will not show, but I'm showing it for clarity in case you need it. So we can see -5s divide out, e to the x divided by e to the x divides out, 2x minus 1 divides out. So we're essentially just left with +1 here. Plus, then we have -5 dividing into +10. So that's actually going to be a -2. So let me back that up. That'll be -2. Then the e to the x's divide out, And then we have 2x minus 1 squared divided by 2x minus 1. So that will leave us with just one quantity of 2x minus 1. So this is technically factored, although I would certainly prefer to simplify that very last quantity. So negative 5e to the x times the quantity 2x minus 1 times the quantity 1 minus 4x plus 2. So I just distributed the negative 2 here. And then we continue to combine like terms, and that last quantity looks to give us negative 4x plus 3. So here's my fully factored form. And again, we know we're fully factored here. We can see this product and this product here. To factor is to rewrite an expression as a product. Lastly, the big kahuna here, we want to factor, and this looks really ugly because we have fractions and we have negative exponents. There's a lot going on here, but we will use the same strategy. We can do it. So we need that greatest common factor. So starting by looking at the coefficients, we have 1/4 and 3/4. We could factor out a 1/4. And then taking a look at the portions that have the exponents, x to the negative 1/4 and x to the negative 5/4. Again, remembering we want to take the smaller exponent, and the smaller of those two exponents is negative 5/4 because we're talking about negative numbers. So my greatest common factor of 1/4 x to the negative 5/4 gets factored out. And then I'm rewriting this as a product. Let me erase up here and show that division once more. So we're dividing each of these terms by 1/4 x to the negative 5/4. Then we'll simplify. So 1/4 divides into 1/4. Those divide out and equal 1. We have x to the negative 1/4 divided by x to the negative 5/4. Off to the side here, let's think about those fractions. So the numerator fraction is negative 1/4, and because we're dividing, we know rules of exponents there, we're going to subtract the fraction in the denominator. So negative 1/4 minus negative 5/4 will really leave us with negative 1/4 plus 5/4, which is 4/4, which is just 1. So this will leave us with x essentially to the first power, but we know we don't typically write an exponent of 1. Moving right along, then we have a plus. Now here we have 3/4 divided by 1/4. So we're just doing straight division there. 3/4 divided by 1/4, which we know is the same as multiplying by the reciprocal. So 3/4 times 4/1, which in this case would just be 3. So we're going to have a coefficient of 3. And then notice we have x to the negative 5/4 divided by x to the negative 5/4. Those completely divide out. That's equal to 1. So in this case, our factored form looks like this. 1/4 times x to the negative 5/4 times the quantity x plus 3.